Welcome back to U.S. Command Intelligence. For most of the modern era, military power has been defined by technological superiority. The assumption was straightforward. If you could build faster systems, more precise weapons, and more advanced detection networks, you would dominate the battlefield. That model shaped decades of defense planning. It influenced how systems were designed, how budgets were allocated, and how conflicts were expected to unfold. But what is happening now is challenging that model in a way that is both subtle and significant. The shift is not coming from a breakthrough in advanced technology. It is coming from a change in how existing technology is being used. Iran's approach to drone warfare represents that shift. Instead of focusing purely on creating the most advanced individual system, it is focusing on creating a network of systems that can operate together at scale. This difference may seem small at first, but it fundamentally changes how pressure is applied in a conflict environment. A single advanced system is designed to perform at a high level under controlled conditions. A network of simpler systems is designed to create conditions that are no longer controlled. That distinction is where the real story begins. When a single drone enters a defended airspace, it is detected, tracked, and intercepted. The system functions as intended. There is no disruption. There is no uncertainty. But when that single drone becomes 10, and then 50, and then 100, the situation begins to change. Not because the technology suddenly stops working, but because the environment in which it is operating becomes more complex than it was designed to handle. Every defensive system has thresholds. These thresholds are not flaws. They are design realities. A radar system can track only a certain number of objects simultaneously with full accuracy. A command system can process only a certain number of engagement decisions within a given time window. An interceptor system can engage only a limited number of targets before it needs to reload or reposition. Under normal circumstances, these thresholds are sufficient. They are built around expected threat levels. Drone swarms are designed to exceed those expectations. They do not aim to defeat the system directly. They aim to stretch it. When multiple drones approach from different directions, at varying speeds and altitudes, the defensive system is forced into a continuous state of decision-making. It must determine which targets are most critical, which can be delayed, and which can be ignored. These decisions are not made in isolation. They are made under time pressure, with incomplete information, and with the understanding that any miscalculation could allow a threat to pass through. This is where the concept of saturation becomes critical. Saturation is not about destroying a system. It is about overwhelming its ability to process inputs effectively. When the number of incoming objects exceeds the system's processing capacity, performance begins to degrade. Tracking becomes less precise. Prioritization becomes more difficult. Response times increase. And in that environment, even a small number of successful penetrations can have a significant impact. This is the core logic behind swarm-based strategies. They do not require every unit to succeed. They only require enough pressure to create openings. Now introduce another dimension that amplifies this effect: cost. The economic structure of swarm warfare is inherently asymmetric. A single drone can be produced and deployed at relatively low cost. It does not require complex infrastructure. It does not require long production cycles. It can be replaced quickly if lost. On the defensive side, the systems required to intercept that drone are often significantly more expensive. This creates a situation where the cost of defense exceeds the cost of attack. In a short engagement, this imbalance may not be significant, but over time it becomes strategically important, because sustained conflict is not just a test of capability. It is a test of endurance. If one side can continue applying pressure at a lower cost, while the other must expend higher value resources to respond, the balance begins to shift gradually. This is not a sudden collapse. It is a slow erosion of efficiency. Each interception consumes resources. Each engagement requires coordination. Each response adds to the operational burden. Over time, this burden accumulates, and as it accumulates, the margin for error decreases. This is where drone swarms become particularly effective. They introduce not just physical pressure, but systemic pressure. They force defense systems to operate continuously, without pause. They increase the number of variables that must be managed simultaneously. They reduce the predictability of the environment. And in doing so, they create conditions where even advanced systems can be challenged. There is also a technical dimension that further complicates the situation. Drones operate in a way that differs significantly from traditional threats. They often fly at lower altitudes, closer to terrain, which can reduce detection ranges. Their speeds are slower, which can affect tracking algorithms optimized for faster-moving objects. Their radar signatures are smaller, sometimes blending with environmental noise or clutter. These factors do not make drones invisible, but they make them more difficult to manage when deployed in large numbers. And again, scale is a defining factor. A small number of drones can be handled efficiently. A large number introduces complexity. And complexity is where systems begin to show limitations. From the perspective of the United States, this presents a challenge that is both technical and strategic. The existing defense architecture is highly advanced. It is designed to intercept high-value threats with precision and reliability. But adapting that architecture to handle large-scale, low-cost swarm threats requires a different approach. It requires systems that are not only effective individually, but scalable collectively. This is why there is increasing focus on developing new types of countermeasures. Lower-cost interceptors that can be deployed in greater numbers. Automated detection systems that can process information more quickly. Layered defenses that distribute the workload across multiple systems rather than concentrating it in a few high-value assets. These developments represent an important shift in thinking, from precision to scalability, from individual performance to system-wide resilience. But these changes do not happen instantly. Large defense systems evolve through cycles of development, testing, and integration. And during that time, the threat continues to evolve as well. This creates a dynamic environment where both sides are adapting simultaneously. One side is increasing pressure through scale. The other is attempting to increase capacity through innovation. The outcome of this interaction is not determined by a single event. It is determined over time, through repeated engagements, through incremental adjustments, through the accumulation of small advantages. This is what makes the current situation so significant. It is not just a tactical development. It is a strategic shift. It challenges long-standing assumptions about how military power is applied. It introduces new variables into the calculation of risk and response. And it forces a reevaluation of how future conflicts will be fought. Other countries are observing this closely, because the implications extend beyond a single region. If scale-based strategies can consistently challenge advanced systems, then the barriers to entry for effective military capability are lowered. This changes how smaller powers think about defense. It changes how alliances calculate strength. It changes how deterrence is perceived. And over time, it changes the balance of power. Not through a single decisive event, but through a gradual shift in how systems perform under pressure. This is why the current moment matters. It is not just about what is happening now. It is about what this represents for the future. Drone swarms are not replacing traditional weapons. They are adding a new layer to the battlefield, a layer that operates on different principles, a layer that prioritizes scale over precision, pressure over perfection, sustainability over single-event dominance. And once that layer is fully integrated, it becomes a permanent part of how conflicts unfold. The question now is not whether this approach is effective. That has already been demonstrated. The question is whether existing defense systems can evolve quickly enough to maintain their effectiveness in this new environment. Because if they cannot, the shift will not be immediate. It will be gradual. And that kind of shift is often more difficult to detect and even more difficult to reverse. Drop your analysis in the comments. Do you see this as a temporary adaptation or a long-term transformation in how wars are fought? If this breakdown gave you real clarity, like, share, and subscribe. Stay sharp, stay informed. We will see you in the next one.